Hello. Yeah, hello. Wait a minute, sir. Right. Hello. Wait, sir. Hello. Hello. Yes. Start. Start now. వస్తుందా ఇక్కడ పెట్టుకుంటే హలో ఓకే మొత్తం క్లోజ్ చేద్దామా. Yes, today I am going to discuss about diploma engineering chemistry topic, water and its treatment. Water and its treatment. First of all, I would like to introduce about source of water. Source of water. What is source of water available? Here one is groundwater. One is groundwater. Groundwater means what now? What is that? Pond, and what is that? Borewell water, etc. is treated as what more? Groundwater. And second one is what more? Surface water. Surface water. Surface water, majorly rainwater, river water, lake water, etc. is said to be what more? Surface water. These two are what more? Naturally occurring sources only. It is naturally occurring sources only. Here this naturally occurring source contains lot of impurities and dissolving salts. Lot of impurities and dissolving salts. Here these salts and impurities and minerals etc. are going to add into the water. But here one thing, the human beings nowadays for drinking purpose not required that much dissolving salts and other impurities are not required for drinking purpose. That purpose we need to study what is hardness and how to remove hardness etc. topics. Now I would like to introduce what is hard water. What is hard water? This is very important for examination point of view. Hard water, what is the definition? Here what is hard water? The water which do not gives lather with soap is called what more? Hard water. Here what is the definition of hard water? The water which does not produces lather with soap is called hard water. HW, hard water. It means what is the chemical formula of soap? Hard water means which contain dissolving salts. For example, what is soap chemical formula? C17H35COONA, sodium salt of stearic acid. This compound is said to be what more? Soap. Whenever combined with any one of the dissolving salts you can take. For example, magnesium chloride I am taking. Dissolving salt. By dissolving of this magnesium chloride, here hardness occurs water. Here this one is combining 2 moles of soap. Here form like this: C17H35COO 2 times and magnesium. What is remaining? Here 2 sodiums and 2 chlorines are formed like this, 2 NaCl as a byproduct. Here by forming like this compound, this precipitation to form, that's why immediately do not come lather with this hard water. Here similarly we have soft water. soft water. Soft water means, here what is the definition? The water which gives much lather with soap. The water which gives much lather with soap is called what more? Soft water. The water, here I am writing, the water which gives much lather with soap is called soft water. Here once again I am repeating, the water which gives much lather with soap is called soft water. Soft water means which do not have any salts, which do not have any dissolving salts. Due to dissolving salts of calcium and magnesium, here the water occurs hardness more. And also some cases, some traces of heavy metals also to produce hardness. Here directly whenever soap is going to react with soft water, which means only H2O, they do not have any dissolving salts, only H2O is directly going to react, they produce what more? C17H35 COOH plus remaining NaOH to come. This is hard and soft water. Once again I am repeating, hard water means the water which does not produces lather with soap is called what more? Hard water. Whenever hard water reaction takes place like this manner, C17H35 COONA is going to react with magnesium chloride to obtain what more? Like C17H35 COO2 Mg plus 2 NaCl. That is hard water. Next, soft water, the water which gives much lather with soap is called soft water. The soft water reaction this. Next I am going to explain about next one. Here types of hardness of water. Hardness causing salts. Now I am going to explain what more? Hardness causing salts. Then after I would like to explain types of hardness of water. Here hardness causing salts. What are the salts causing or responsible hardness? What are the salts causing or responsible hardness causing salts mean? The following salts are causing hardness means bicarbonates, chlorides, sulfates, nitrates of calcium and magnesium are responsible hardness. Here calcium and magnesium salts are responsible. Calcium and magnesium salts are responsible hardness causing salts. Here what exact salts are responsible hardness causing salts means what more? Bicarbonates of calcium and magnesium. Next chlorides of calcium and magnesium. Sulfates of calcium and magnesium. Nitrates of calcium and magnesium. Here calcium and magnesium bicarbonate CaHCO3 taken twice, calcium bicarbonate and magnesium bicarbonate. Next chloride CaCl2 MgCl2. Next sulfate CaSO4 MgSO4. Next nitrates calcium nitrate, magnesium nitrate. These are the salts responsible hardness. Mainly these salts are going to dissolve in water, the water occurs hardness. If in case these salts are absent, the water do not have any hardness, which means completely that water is free from the hardness. Whenever dissolving these salts in water, the water occurs hardness. Completely these following salts are absent in the water. The water do not having any hardness, do not have any hardness. Here based on these salts, based on the dissolving salts, here hardness of water divided into two types. Hardness of water is going to divided into two types. Here hardness of water, hardness of water. Hardness of water, before going to types of hardness of water, I am giving this hardness of water definition. Once listen. Previously, I gave the definition of hard water. What is hard water? The water which does not give much lather with soap is called what more? Hard water. Here, what I am giving the definition of hardness of water. The property of hard water which prevents the formation of lathering with soap. Here, what I am giving, listen carefully. The property of hard water which prevents the formation of lather with soap. The property of hard water, the property of hard water which prevents the formation of lather with soap is called what more? Hardness of water. Depending on the dissolving salts, here this hardness of water is classified into two types. This hardness of water is going to classified into two types. Now I would like to explain that one. Types of hardness of water. Types of hardness of water. Types of hardness of water. You listen here. Here first one, temporary hardness of water. Temporary hardness of water. Temporary hardness of water. Here bicarbonates of calcium and magnesium. Bicarbonates of calcium and magnesium are responsible this temporary hardness. Here what more? Calcium and magnesium bicarbonates are responsible temporary hardness. This hardness can be removed by boiling. Here what is this? Calcium and magnesium bicarbonates are responsible temporary hardness. Calcium and magnesium bicarbonates are responsible this hardness okay. This hardness can be removed by boiling. Here what more? This hardness means temporary hardness. This hardness can be removed by boiling. Just simply boil the water, it can be removed. This hardness can be removed by boiling. Here you can see the reaction how to remove hardness. Here calcium bicarbonate and magnesium bicarbonate is an examples of temporary hardness. First of all, I am writing calcium bicarbonate reaction. Calcium bicarbonate whenever boiling means you can write delta symbol indicates what more? Boiling. Delta symbol indicates boiling. This calcium bicarbonate is going to convert into calcium carbonate plus CO2 plus H2O vapors. Here this one is present as a downward arrow mark. This one is called what more? Precipitation. PPT means precipitation, which means insoluble substance substance. Here, before the boiling, this calcium bicarbonate present in water as what was soluble state. Soluble state compound. After the boiling, it is going to convert into what was insoluble PPT. Insoluble PPT, how can you separate? Whenever insoluble PPT is formed, it can be separated by filtration process. That's why which is going to remove from the water, which means temporary hardness can be removed by boiling process. This carbon dioxide on upward arrow mark, which means gas, and also water upward arrow mark, which are going to gas state. Similarly, I am writing next also magnesium bicarbonate on boiling, which indicates what was this one also soluble state. Before boiling it is soluble in state. After the boiling to come here magnesium hydroxide, it is what was insoluble, it is going to convert into insoluble substance. That's why which is going to separate by filtration process. Then here to come 2 moles of carbon dioxide to come. These are the reactions following in what more temporary hardness. Whenever boiling, calcium bicarbonate is going to convert into calcium carbonate insoluble substance, and magnesium bicarbonate on boiling is going to convert into insoluble substance of magnesium hydroxide. By taking place this chemical reaction, what more temporary hardness can be removed by boiling. Temporary hardness can be removed by boiling. Here exam point of view, what is temporary hardness? What is temporary hardness is possible in the examination. We need to write here what is the answer. Calcium and magnesium bicarbonates are responsible temporary hardness. This temporary hardness can be removed by boiling method. These 2 chemical reaction we need to write in the examination. Next we have second one permanent hardness of water. Permanent hardness of water. You listen here. After completion of temporary hardness, we have permanent hardness of water. Here listen more. Permanent hardness of water majorly responsible calcium and magnesium chlorides, sulfates, nitrates, etc. are going to responsible. Chlorides, sulfates and nitrates of calcium and magnesium. Responsible this hardness, permanent hardness. What more permanent hardness? What more is going to responsible? Chlorides, sulfates, nitrates of calcium and magnesium responsible. Here, what are exact this hardness? This hardness cannot be removed by boiling. Listen to it. Here this hardness cannot be removed by boiling. It can be removed by some specific methods like zeolite method, lime soda method, ion exchange method, etc. This hardness can be removed some specific methods like zeolite method, lime soda and ion exchange process. Etc. Here what are going to methods? This hardness can be removed some specific methods like zeolite, lime soda and ion exchange process. These types of hardness of water, these two possibility questions in the examination, what is temporary hardness, this definition, this information, and permanent hardness information and examples I am showing in the next page. Here permanent hardness, what are examples? Chlorides, sulfates, nitrates of calcium and magnesium means here what more? Calcium chloride, comma magnesium chloride are responsible permanent hardness, and calcium sulfate, comma magnesium sulfate also responsible permanent hardness, and calcium nitrate, comma magnesium nitrate also responsible temporary hardness, permanent hardness. These are the salts responsible permanent hardness, except bicarbonates of calcium and magnesium, remaining salts are responsible permanent hardness of water. Okay. Next we have continuation topics. Here after types of hardness of water we have continuation topics in diploma. Here what more? Units for hardness of water. Units for what more? Units for hardness of water. What are the units for hardness of water more? Here first unit is ppm. Parts per million. Parts per million. Parts per million more. ppm means what more? Parts per million. Here what is ppm? Parts per million, its full form. Here what is the definition of ppm? Here 1 part of CaCO3 equivalent hardness, 1 part of CaCO3 equivalent hardness present in what more? 10 to the power of 6. 10 to the power of parts by weight of water is known as what more? ppm. Here 1 ppm is equals to 1 part of CaCO3 equivalent hardness present in 10 to the power of 6 parts, 10 to the power of 6 parts by weight of water is said to be what more? ppm. What is the definition of ppm? 1 part of CaCO3 equivalent hardness of water present in 10 to the power of 6 parts by weight of water is called what more? ppm. Next in the similar manner we have second unit milligram per liter. Milligram per liter, which is represented as mg per liter. This one also similar to ppm. Here milligram per liter is equals to mg per liter is equals to, here what is definition? 1 part of CaCO3, 1 part of CaCO3 equivalent hardness present in what more? 1 liter of water. 1 liter of water. Here what are going to take? Here 1 liter is equals to what more? Just assumption 1 kg. 1 kg is equals to 1000 grams. 1 kg is equals to what more? 1000 grams. 1000 grams is going to convert into milligrams. Here this 1000 grams is going to convert into milligrams. Again it is going to multiply with 1000 totally to come 10 to the power of 6 milligrams more. 6 milligrams, which means 1 liter is equals to what more? Here milligram per liter, which means what more? 10 to the power of 6 parts. 10 to the power of 6 part milligrams, which means 1 part of CaCO3 equivalent hardness present in what more? 1 liter of water. 1 liter of by weight of water, which means 1 liter is equals to explanation. 1 liter is equals to assumption as 1 kg is equals to 1000 grams is equals to 1000 into 1000, it is going to convert into milligrams, which means finally to got 10 to the power of 6. This one also 10 to the power of 6. This one also 10 to the power of 6, which means here what one part of CaCO3 hardness present in this one also 10 to the power of 6 parts by weight of water, which means 10 to the power of 6 parts by weight of water, which means therefore 2 units are going to equal 1 ppm is equals to 1 milligram per liter. Why means both are in 10 to the power of 6, 10 to the power of 6, 10 to the power of 6. Here units exactly equal. 1 ppm is equals to 1 milligram per liter. 1 ppm is equals to 1 milligram per liter. These two units are exactly equal. Next we have third unit, Clark degree. Clark degree, which is represented like this. Here Clark degree, one of the another unit for hardness of water. Here how to define this? 1 degree Clark is equals to 1 part of CaCO3 equivalent hardness. CaCO3 equivalent hardness. CaCO3 equivalent hardness present in 70,000 parts by weight of water. Here what more? 1 part of CaCO3 equivalent hardness present in 70,000 parts by weight of water is said to be what more? Clark degree. Next fourth one, French degree. Here the French degree definition, 1 degree French is equals to 1 part of CaCO3 equivalent hardness. CaCO3 equivalent hardness present in 10 to the power of 5 parts. 10 to the power of 5 parts by weight of water. It is said to be what more? French degree. Here 4 units I say. First unit ppm, second unit milligram per liter, third unit Clark's degree, fourth unit French degree. These 4 units are correlated with this following relation. The relation between these 4 units, the relation between various units. I am writing here, listen. 1 ppm is equals to 1 milligram per liter is equals to 0.07 degree Clark is equals to 0.1 degree French. This is the basic relation between these 4 units. Here what is the relation? 1 ppm is equals to 1 milligram per liter is equals to 0.07 degree Clark is equals to 0.1 degree French. 0.1 degree French. These 4 units and its relation, etc. After that we have how this hardness is going to expressed. How this hardness is going to express. Here expression of hardness of water. Expression of hardness of water. Here hardness of water expressed in terms of calcium carbonate equivalents. Here what more? Here HW. Hardness of water is expressed in terms of calcium carbonate equivalents. Why? Because why it is expressed in terms of calcium carbonate equivalents, not in other equivalents? Here because of its calcium carbonate is almost insoluble substance in almost solvents. Why means this calcium carbonate is insoluble substance in almost solvents. Here what is the reason? What is the reason expression? What is the reason for expression of this calcium carbonate equivalent means calcium carbonate almost insoluble in insoluble in almost solvents. Calcium carbonate insoluble in almost solvent. This one is not required. Almost insoluble in almost solvents. Next, calcium carbonate gram equivalent. This calcium carbonate gram molecular weight is equals to 100, round figure number 100, and also gram equivalent weight is 50. During the calculation of sums also, it very easy to calculation of sums by taking gram molecular weight as 100 and gram equivalent weight taking as 50. Here the hardness of water expressed in the following formula: hardness of water in terms of CaCO3 equivalence is equals to, what is formula? Weight of salt divided by GMW of salt, which means dissolving salt, into 100. What is this 100? This 100 is belongs to what more? This gram molecular weight of calcium carbonate. Here hardness of water expressed in terms of calcium carbonate equivalents, right? Here the formula is given, what more? Hardness of water in terms of calcium carbonate equivalents is equals to weight of dissolving salt divided by gram molecular weight of dissolving salt into 100. Similarly, we have another formula also. Whenever using gram equivalent weight is equals to weight of salt divided by gram equivalent weight GW of salt into 100. Hardness of water in terms of calcium carbonate equivalents is equals to, this is one formula and also this one is one formula. Oh sorry, here one small error is there. Here whenever you are taking what more? Gram equivalent weight. What is gram equivalent weight? 50. It is going to multiply with 50. Okay, this you can change. Weight of salt divided by gram equivalent weight of salt into 50 whenever taking gram equivalent weight. Similarly, based on this formula, I am showing one problem. Just check it. Based on the previous problem, one problem I am giving. First one I am giving. Problem I am writing. 6.8 grams. 6.8 grams of calcium sulfate was dissolved in 1 liter of solution. Then calculate hardness of water. Here this one you can change units, milligrams you can write. 6.8 milligrams of calcium carbonate was dissolved in 1 liter of solution. Then calculate calculate hardness of water. Here, how to solve this problem? Here given information, the weight of calcium carbonate 6.8 milligram in 1 liter means what is given more? Here weight of salt given, which is calcium sulfate, is equals to 6.8 milligram per liter. Milligram here given, liter is here given. And what is its gram molecular weight? GMW of CaSO4 calcium sulfate, GMW 136 mol. This gram molecular weight, how to calculate? Here I am showing calcium sulfate GMW, how to calculate? Here I am showing how many calciums are there? Only one calcium. Calcium atomic number 20, atomic mass 40. One calcium means 40 you can write, only one calcium. Sulfur, how many exist? Only one. Sulfur atomic number 16 and atomic mass 32. Plus how many oxygens are repeated? 4 oxygens are repeated. But oxygen atomic mass is 16, 4 into 16. This one calculate 40 plus 32 plus 64. Totally to come what more? 136. You can calculate like this manner. Compulsory you know the atomic masses of different elements, then only to possible to calculate gram molecular weights of different chemical compounds. Here what is the formula for calculating hardness of water? Here I am writing hardness of water in terms of CaCO3 equivalents is equals to weight of salt divided by GMW of salt into 100. Here given weight of salt given 6.8, GMW 136 into 100. Here what is coming solution? 6.8 divided by 136 into 100 to come only 5 milligram per liter to come. This is the answer. 5 milligram per liter to come. Like this manner we need to calculate hardness of water. This is simple problem I am given, only one salt I am giving. In your major examination they are giving 2 or more salts are given, and they are asking how to calculate temporary and also how to calculate permanent hardness of water. They are asking in the examinations. Now you can say next we have, now I would like to explain what more potable water. What is potable water? Potable. What is potable water? Potable water, the water which is used for drinking purpose. The water which is used for drinking purpose is called what more? Potable water. Directly water is not going to use as a drinking purpose. Whatever the source you collected, either surface or ground, that water no one is going to drink directly. When the people are going to drink that water after the purification, after the treatment of some purification method, it is going to possible to drink many people. Here the water which is used for drinking purpose is called what more? Potable water. Before going to treat it as potable water, the dissolved contaminants must remove from the water. Here I am writing the water which is used for drinking purpose The water which is used for drinking purpose is called potable water. Potable water. Here, before going to treat it as potable water, here what more? Dissolved contaminants we need to remove compulsory. Dissolved contaminants like calcium and magnesium salts, any other impurities, some sand impurities, mud impurities, etc. All impurities are going to remove from the water. Then only the water is treated as what more? Potable water. Dissolved contaminants you must remove. Here I am writing dissolved contaminants. Dissolved contaminants we need to remove from the water. Remove from the water. Remove from the water. All the dissolved contaminants compulsory remove from the water, then only the water is treated as potable water. Here one more question also they are possible. What is potable water? What is potable water means? The water which is used for drinking purpose is called potable water. Before going to treat it as potable water, dissolved contaminants we need to remove from the water. You can explain like that. Next we have specifications of potable water. You listen. Specifications of potable water. Specifications of potable water. Here potable water having some specifications. First one, the potable water do not have any potable water should not have any color and odor and taste. Here potable water should not have any color, odor and taste means it should be colorless, odorless, odorless and tasteless. Tasteless. Here it should be colorless, odorless and tasteless. Next, it should free from dissolved contaminants. Here compulsory it should free from dissolved salts like calcium and magnesium salts. It should free from dissolved gases like carbon dioxide, carbon monoxide, hydrogen sulfide, etc. gases also not required. Next, it should free from dissolved poisonous gases. It should free from dissolved poisonous metal. Here once again I am writing. It should free from dissolved poisonous metals like mercury, lead, arsenic, etc. What are they? It should free from dissolved poisonous metals like mercury, lead, arsenic, etc. And one more, here what more? The hardness of water should not exceed 125 ppm. Hardness of water should not exceed 125 ppm. Mostly more than 125 ppm hardness of water cannot preferred. That is the quality. And sixth one, total dissolved solids, TDS. TDS. TDS means what more? Total dissolved solids. TDS means what more? Total dissolved solids. Total dissolved solids should not exceed 500 ppm. 500 ppm. Here what more? TDS, total dissolved solid, is different and hardness of water is different. Hardness of water is coming from only calcium and magnesium salts whenever dissolving. TDS is coming from calcium and magnesium salts whenever dissolving, any other impurities dissolving, any other impurities, any other metal dissolving, all dissolving substances should come TDS. Only calcium and magnesium salts whenever dissolving, hardness to come. Hardness means only calcium and magnesium salts. Total dissolved solid means every impurity whenever dissolving the water, that is said to be what more? Dissolving, total dissolved solids. After that, total dissolved solids. After that, next we have seventh one, the pH of water. The pH of water in between 7.5 to 8.5. The pH of potable water in between 7.5 to 8.5. 7.5 to 8.5. And also eighth point, fluorides should not exceed 2 ppm. Only 2 ppm. Fluoride should not exceed 2 ppm. Here, whenever fluorides are more in water, to occurs fluorosis. Mainly it occurs teeth decay and bone decay, etc. takes place whenever drinking more fluoride containing water, whenever the people are going to taking for drinking purpose. Next, last point, ninth point I am going to explain. Potable water should free from dissolved, the potable water completely free from disease caused microorganisms. Here what more? It should free from disease cause microorganisms like what more? Bacteria, virus, fungi, etc. like bacteria, virus and fungi, etc. These are the few essential specifications of potable water. అయిపోతలేగా, టైం ఎక్కువ తీసుకుంటుంది. నా క్లాస్ ఉంది మళ్ళీ 7:30. స్టాప్ చేద్దామా, మళ్ళీ కంటిన్యూ చేద్దాం? నాకు క్లాస్ ఉంది 7:30కి, హోమ్ ట్యూషన్. అంతేంట. ఒక్క నిమిషం ఆగు, మళ్ళీ చేస్తా. Just you can take break 10 minutes. After 10 minutes it will continue the class. You can take 10 minutes break. After 10 minutes you can join.
ఇక్కడ మెసేజ్ చేయండి బేటా, కింద కామెంట్ సెక్షన్లో మెసేజ్ చేయండి ఒకసారి. మీ ఎగ్జామ్ ఎలా రాశారు ఈరోజు? ఎగ్జామ్ బాగా రాస్తే జస్ట్ కామెంట్ సెక్షన్లో రాయండి. వెరీ గుడ్ ఈవినింగ్ టు ఆల్, వెరీ గుడ్ ఈవినింగ్ టు ఆల్ బేటా. సో జస్ట్ యూ కెన్ సే ఎగ్జామ్ ఎలా రాశారు ఈరోజు? బాగా రాశారా? సో ఎగ్జామ్ బాగా రాశారా అందరూ? ఏమొచ్చినాయి క్వశ్చన్స్? నేను చెప్పినవి వచ్చినాయా లేకుంటే డిఫరెంట్గా వచ్చినాయా? 5 మార్క్స్ క్వశ్చన్స్ ఆల్మోస్ట్ వాట్ ఎవర్ ఐ డిస్కస్డ్ ఆల్ క్వశ్చన్స్ ఇన్ ద ఎగ్జామినేషన్. కైనెటిక్ ఎనర్జీ ఎక్స్ప్రెషన్ కూడా మనం మాట్లాడుకున్నాం. v² - u² = 2as. అక్కడ నుంచి మనం కైనెటిక్ ఎనర్జీని ఫైండ్ అవుట్ చేస్తామని చెప్పిన. అక్కడ u = 0 అయితే v² = 2as. దాన్ని తీసుకుపోయి ఎక్కడ సబ్స్టిట్యూట్ చేయాలని చెప్పిన. అక్కడ నుంచి నువ్వు ఏని బయటికి తీసుకో. ఏ ఈక్వల్ ఏమవుతుంది? v² / 2as అవుతుంది. అక్కడ నుంచి ఏం చేస్తావు? దాన్ని తీసుకెళ్ళి వర్క్ w = fs ఉంటుంది కదా, దాంట్లో సబ్స్టిట్యూట్ చేస్తే అక్కడ ఎస్ఎస్ క్యాన్సిల్ అయితే ½ mv² అని వస్తుంది. దట్ ఈస్ వర్క్ ఈజ్ నథింగ్ బట్ ఎనర్జీనా. సో అదో క్వశ్చన్ 5 మార్క్స్కి వచ్చింది. నేను 2 సార్లు చెప్పిన మీకు, ఆల్మోస్ట్ ఫ్రీలీ ఫాలింగ్ బాడీ దగ్గర ప్రతి ఈచ్ అండ్ ఎవ్రీ పాయింట్ షుడ్ బి ఈక్వల్ అమౌంట్ ఆఫ్ ఎనర్జీ ఉంటుందని చెప్పిన. అది కూడా 5 మార్క్స్ క్వశ్చన్ వచ్చింది. ఇంకోటి ఇంకొక పాయింట్ ఏంటంటే, ఎగ్జామినర్ అడిగాడు, మనం ఫస్ట్ హీట్ ట్రాన్స్ఫర్లో ఇక్కడ చెప్పిన ఏంది, లెంత్లో చేంజ్ అవుతుంది, ఏరియాలో చేంజ్ అవుతుంది, వాల్యూమ్లో చేంజ్ అవుతున్నప్పుడు ఎలాంటి టైప్ ఆఫ్ ది డిఫరెంట్ కైండ్ ఆఫ్ ది లైక్ ఆల్ఫా, బీటా, గామా మూడింటి గురించి చెప్పినాం. దట్ ఈస్ కాల్ లీనియర్ ఎక్స్పాన్షన్, ఏరియల్ ఎక్స్పాన్షన్ అండ్ వాల్యూమ్ ఎక్స్పాన్షన్. ఈ మూడింటి గురించి అతను లాస్ట్ క్వశ్చన్ అడగడం జరిగింది. ఇంకొకటి ఇంపార్టెంట్ క్వశ్చన్ ఏంటంటే, నైటు మీకు ఒక వీడియో చేశాను చూసారా, ఐసోథర్మల్ ప్రాసెస్ గురించి అడిగిండు. సో దీని గురించి మీరు క్లియర్గా చెప్పాలంటే ఫస్ట్ ఆ డిఫరెన్సెస్ కూడా మనం లాస్ట్ వీడియోలో నైట్ చేసిన 10 o'clockకి అది అప్లై చేసినప్పుడు క్లియర్గా మెన్షన్ చేసిన బెట్ట మీ అందరికీ. సో ఒక్కసారి మీరు లైక్ వేసుకోండి ఫాస్ట్గా, ఒక్క లైక్ వేసుకోండి అందరూ ఫాస్ట్గా లైక్ వేసుకోండి. ఇక లైక్ చేయని వాళ్ళు చాలామంది ఉన్నారు, లైక్ వేసుకోండి ఫస్ట్ ఇమీడియట్గా. ఇమీడియట్ లైక్ వేసుకోండి బేటా. సో ఎగ్జామ్ ఎలా రాశారు? ఎగ్జామ్ ఎలా రాశారు? వెరీ గుడ్ ఈవినింగ్ టు ఆల్. ఫస్ట్ మీరు అందరు గుడ్ ఈవినింగ్ చెప్పండి, హలో గుడ్ ఈవినింగ్ చెప్పండి. సో మీకు ఎవ్రీ కాన్సెప్ట్, ఈచ్ అండ్ ఎవ్రీ కాన్సెప్ట్ 3rd, 5th, లాస్ట్ 5th and 6th యూనిట్లో కంప్లీట్గా మీకు కంప్లీట్ అయిపోతుంది. సో కంప్లీట్ అయిపోతుంది, మీరు డెఫినెట్గా లైవ్లో కంటిన్యూ కాండి. సో ఇంకెవరైనా స్టూడెంట్స్ ఉంటే వాళ్ళకి తెలిసిపోతుంటుంది కాబట్టి డెఫినెట్గా, ఇంకా మీరు ఇక్కడ సబ్స్క్రైబ్ చేసుకున్నట్టున్నారు, జస్ట్ డూ ఇట్ సబ్స్క్రైబ్ ఇమీడియట్లీ. సో ఎగ్జామ్ ఎలా రాశారు బేట అందరు? సూపరా, ఎక్సలెంటా, నైస్లీయా? ఒకసారి రాయండి ఫాస్ట్. మీరు కామెంట్ చేయాలి బేట, అందరు కామెంట్ చేయాలి, కామెంట్ ఇమీడియట్లీ. సో ఫాస్ట్గా కామెంట్స్ వస్తూ ఉండాలి. మీకు ఇక్కడ ఏమొస్తుంది? వెరీ గుడ్ ఈవినింగ్. సో చూడండి, మీరు కామెంట్స్ చేస్తూనే ఉండండి బేటా. ఓహో ఓకే. సో నేను లాస్ట్ వీడియో చేశాను కదా, ఒకసారి ఓపెన్ చేసి చూడండి. ఈరోజు వచ్చిన క్వశ్చన్స్ అందులో ఉన్నాయా లేవా ఒకసారి చూడండి బేటా, మీరు చూస్తే మీకు అర్థమవుతుంది. డిసడ్వాంటేజెస్ ఆఫ్ యూజింగ్ హాట్ వాటర్ ఇన్ ఇండస్ట్రీస్ టాపిక్ చెప్పు అన్నా. ఎస్, అవన్నీ థియరీ క్వశ్చన్స్ సార్ చెప్తారు డెఫినెట్గా. సో ఎక్సలెంట్ రాశారా అందరూ? రైట్. సో ఇంకా రావాలి ఆన్లైన్లోకి, మీరు అందరూ వస్తుంటే లైక్ వేసుకోండి ఫస్ట్, మీరు సబ్స్క్రైబ్ చేసుకోండి ఇమీడియట్గా. సో సబ్స్క్రైబ్ ఈరోజు ఎవరు చేయనట్టున్నారు? ప్లీజ్ డూ ఇట్ ఫాస్ట్. We will reach us to 5K. Okay. So sir will come now and he will take the all electrochemistry. Mostly electrochemistry సార్ తీసుకుంటారు. ఓకేనా? రైట్ బేటా. సో ప్లీజ్ వెల్కమ్. mobiles.
Welcome to continue the class after the break, students. After the refreshment, again I welcome to you all. Again I am going to continue the classes. After essential qualities or essential specification of potable water, now I would like to explaining water softening methods. Water softening methods in your syllabus we have zeolite method, ion exchange method we have in syllabus. One by one I am going to explain that methods. Here water softening methods. Water softening methods, according to your syllabus we have in two methods. One is zeolite method and another one is ion exchange method. First one, zeolite method or permutate method. Zeolite method or permutate method. Here the hard water we are collecting from the source. Hard water we are collecting from the source and taking in this method and adding of zeolites. Adding of zeolite, here we need to remove dissolving salts like calcium and magnesium bicarbonates maybe, or chlorides, sulfates, nitrates, whatever dissolved in the water. Here what are zeolites? Here what are zeolites? Here zeolite, here naturally occurring zeolite you are going to use. Sodium zeolite is going to use for the removing of dissolving calcium and magnesium suspended impurities from the water. Here exactly sodium zeolite. Sodium zeolite. Here what are going to use? Sodium zeolite is going to use. What exact zeolite is going to use? Sodium zeolite. Sodium zeolite is going to use for this method. Here what exactly sodium zeolite? Here Na2 Al2 Si2O8, sodium zeolite. Sodium zeolite is going to add this compound, is going to write this complete method is going to write Na2 is going to write as it is, and Na2 is going to write same, zeolite is going to write as Z, where Z is equals to what more? Where Z is equals to Al2 Si2O8, Al2 Si2O8 and also XH2O, XH2O. This complete Z is equals to what more? Every time we don't write like this formula Na2 Al2 Si2O8 XH2O, somewhat difficult during the chemical reaction. This complete term they are going to treat it as what more? Z. Complete term is going to treat it as what more? Z. We are collecting from the water from source. That water we need to enter into the zeolite process. Here the zeolite having a small microporous structure. This compound, the zeolite having a small microporous structure, it can act as like a filter. They have small microporous structure. Whenever water is coming towards zeolite, this zeolite can act as like a filter, which allows only water molecules, do not allows dissolving suspended impurities. Dissolving suspended impurities are stopped on the surface of zeolite bed. A small diagram I am going to explain. A small container I am taking. In this small container, what I am going to take? Hard water is going to take. What is this? Hard water. Hard water whenever enter into this tank, in middle what I am going to fix? zeolite bed I am going to fix. The zeolite bed having small microporous structure. The zeolite bed having small microporous structure. Whenever water coming here, water coming towards the zeolite bed, the water dissolving calcium and magnesium salts. This water is already dissolved calcium and magnesium salts. Whenever the dissolving salts are coming towards the zeolite bed, the zeolite bed dissolving suspended impurities are stopped on the surface of this bed. Only water molecules are going to coming down, which can stop dissolving suspended impurities on the surface of zeolite bed. What is this? Sodium zeolite, which is written as Na2Z, Na2Z. Okay, here after stopping the impurities on the surface of sodium zeolite bed, the remaining water molecules are getting down. Here water molecules are getting down, and also the pure water is collected from this area. The pure water is going to collected from this area. Pure water or purified water is collecting from this area. Here this area is going to treated as what more? Washings. Here again we need to add here somewhat brine solution. What more? Sodium chloride solution is going to add for this. What purpose sodium chloride is going to add? I am explaining. Here first one, whenever water is coming in this container, this water is going to interact with sodium zeolite. For example, one salt you can take. For example, calcium chloride is present in the water. Calcium chloride is present in this water. This calcium chloride dissolving CaCl2 whenever reaches to the zeolite, sodium zeolite, Na2Z, what is formed? CaZ they form. CaZ. Remaining 2 sodiums, 2 chlorine. Understand here, 2 sodium and 2 chlorines combined to produce 2 sodium chloride. The dissolving salts are this calcium zeolite. Calcium zeolite can stop on the surface of bed here. The calcium zeolite is going to stop in the surface of this bed. In the similar manner, magnesium chloride is combined with sodium zeolite. Again they form magnesium zeolite. Okay, here magnesium and Z is equals to what is the term? Al2 Si2 O8 XS2. Every time no need to mention, I already explained previous only. Z is equals to this term, no need to write here. MgZ you can write. Remaining 2 NaCl to come. Like these salts, magnesium zeolite, calcium zeolite, whatever the salt dissolved in the water, that are going to stop on the surface of this bed. But zeolite have small microporous structure, I say. What did I say more? The zeolite having small microporous structure. This microporous structure allowing only water molecule, do not allows what more? Dissolving suspended impurities like calcium and magnesium. It can stop on the surface of the zeolite bed. Okay. So here this microporous structure, whenever the zeolite method is going to use for long time, this microporous structure has been blocked. The microporous structure has been blocked. Why? Means the microporous structure continuously blocked, which means further filtration cannot possible. Further filtration is not possible. That time we need to regenerate the sodium zeolite resin again. We need to regeneration. Sodium zeolite resin, after using 1 year or 1.5 year or 2 years, this microporous structure 100% it is going to block. Means further filtration that time is not going to possible. That time we need regeneration of zeolite. Here what more? Regeneration of zeolite. How can you regenerate? This exhausted zeolite bed is again regenerated by the addition of brine solution. What is this? Sodium chloride, which is called what now? Brine. Sodium chloride, which is called brine. Here, how to regenerate zeolite? Zeolite resin is regenerated by the addition of brine solution. By the addition of brine solution, or sodium zeolite resin is regenerated by the addition of brine solution. Addition of brine solution. How to regenerate? I am showing here. You take this one, calcium zeolite is combined with what more? Sodium chloride, 2 moles of sodium chloride to produce Na2Z. Na2Z, the reverse reaction, exactly reverse reaction of this previous chemical reaction. Here Na2, 2 Na2 used and Z. What is remaining? One calcium is there, 2 chlorines are there to come what more? CaCl2. Exactly can check it. Opposite reactions, CaZ to NaCl, here opposite reaction to the previous reactions. Okay, you can observe. In the again regeneration, one more reaction also you can see. Magnesium zeolite is combining with 2 sodium chloride to obtain Na2Z and MgCl2. This calcium chloride and MgCl2 can remove from here washing. Calcium chloride, MgCl2 is removed from washings. Here regeneration, these one chemical reaction you learn, another chemical reaction to be easy. Here opposite chemical reaction ma. You can observe here calcium chloride plus sodium zeolite combine CaZ and 2 NaCl. Exactly this first reaction opposite to the third reaction. Again second reaction opposite to the fourth reaction. Like this reactions takes place and continuously to filtration takes place. After the purification, this water is safe for using different purposes. This is zeolite method. Zeolite method. This one is what more? Zeolite method. Here after the zeolite method, we have ion exchange process. Ion exchange process. This one also very important for exam purpose. Ion exchange process. Ion exchange process. Here listen more. Here the basic principle here involved. Principle involved. Here listen. The long chain cross-linked organic polymers are used as the long chain cross-linked organic polymers are used which are containing functional groups. These functional groups can exchange dissolved calcium and magnesium cations and anions like chlorides, sulfates, nitrates, etc. Once again I am repeating, the long chain cross-linked organic polymers or resins are used which are containing functional groups. These functional groups can exchanging hardness producing cation and anion from the hard water. Here what more? Once again I am repeating, the long chain cross-linked organic polymers are used which are containing functional groups. These functional groups can exchange hardness producing cation and anion from the hard water. You see here, this ion exchange process is carried out by 3 steps. Here ion exchange resins, here first one is going to use what more? Cation exchange resin. Here what exchange resin is going to use? Cation exchange resin is going to exchange only cation exchange resin which contain RCOOH. This is carboxylic acid group. And second one, anion exchange resin. This anion exchange resin only can exchange anions R-OH. This is OH functional group, hydroxy functional group, carboxylic acid functional group. These functional groups can exchange hardness producing cation and anion from hard water. Here we have small diagram. Here small diagram I am going to draw. After that I am going to explain. Here we have two containers. Here a small diagram I am going to draw. In middle you can fix what more? Cation exchange resin. The cation exchange resin or anion exchanging resin can exchange. Cation exchange resin can exchange only cations and anionic exchanging resin can exchange only anions. What is this? Cation exchange resin or COOH. Here to come dilute HCl. Here to come hard water. Here you can use pump. Again this water is going to enter into the second tank. In the second tank also you can fix anion exchange resin, anionic exchanging resin which contains microporous structure here which allows only, which can stop only cations on the anions on the surface. This is what more? Anion exchange resin, anion exchange resin R-OH. Here very simple, whenever hard water enter into the, this one is what more? Tank 1, this one is tank 2. Whenever hot water enter into the tank 1, whenever hot water is enter into the tank 1, the dissolved calcium and magnesium salts, for example calcium chloride is going to dissolve in this water cations, calcium plus 2 and 2Cl minus. This one is what? Cation. This one is what? Anion now. One example I am showing, calcium chloride whenever dissolving in the water, calcium plus 2 is treated as cation, positive charged atom is called cation and negative charged atom is called what more? Anion. This cation and anion whenever produced, whenever this water, calcium chloride whenever dissolved in this, calcium plus 2 and Cl minus also is there. This resin, cationic exchanging resin or COOH can stop only cation, this one, only cations can stop here. Calcium plus 2 stopped on the surface of what more? Cationic exchanging resin, the remaining water getting down, Here these are washings. What are coming I will explain later. Washings. This one also washings. Whenever it is regenerated time to come, what are the chemical exactly? After stopping calcium plus 2 here, the remaining water is going to enter into the, with the help of this pump, the water is going to enter into the second tank. This one is first step. Here what was? Step 1. Cation exchange resin or COOH. What's happening? This is the diagram. Whenever calcium chloride present in what more? Water. This one is going to combine with RCOOH. This one is what more? Cationic exchanging resin. Here cations are H plus, here calcium plus 2. This one you can take 2 moles. This cation is coming here, this cation is coming here ma. This H plus is also cation, proton is coming here and this calcium plus 2 is coming here to form RCOO2 calcium plus 2H plus to come. RCOO taken twice, Ca plus 2H plus to come. In the similar manner, one more also I am writing. For example, magnesium chloride to be present in this 2RCOOH combined RCOO2Mg plus 2H plus. Like this reactions takes place. This compound can stop on the surface of resin here. Calcium plus 2 or Mg plus 2 are stopped on the surface. Mostly cations are present in dissolving salts. Whatever the salt dissolved, either bicarbonates, chlorides, sulfates, nitrates, etc. The possible cations, calcium plus 2 and magnesium plus 2. These two ions, these two cations are stopped on the surface of cation exchange resin bed. The remaining water getting down, with the help of this pump, the water is going to enter into the second tank. Here, second tank, whenever enter, here only anions are going to stop. Like what are anions? Chlorides, like sulfates, nitrates, etc. ions are going to removed from these areas. Next, I am going to explain step 2. I am writing step 2. What happened? Step 2. What is heading? Anion exchange resin. Anion exchange resin, which is written as formula R-OH. For example, in this case, chloride 1 anion, which is going to combine with R-OH. In this OH is minus, this minus and this minus. This minus is coming in this place, this minus is coming this place. Mutual exchange. Here this OH minus is coming here, Cl minus is coming here, and what is going on? In R-Cl to come and OH minus is separating. All these reactions can take place in what more? This step. This reaction, all the anions can stop here. Cl minus, HCO3 minus, SO4 2 minus, etc. ions are going to stop on the surface bed of anionic exchanging resin. Surface bed of anionic exchanging resin. Here similarly, for example, HCO3 bicarbonate anion is present, which is going to combine with R-OH. They form R-HCO3 and forming OH minus. The similar manner, SO4 minus 2 present, it is going to react with 2 moles of R-OH, which is going to form R-2 SO4 and remaining 2 OH minus to form. All these compounds are stopped on the resin bed of anionic exchanging resin, which means what is concluding point here? Cationic exchanging resin can be exchanging only cations like calcium plus 2 and magnesium plus 2. Then further the water is going to enter into the tank to here anions like Cl minus, HCO3 minus, sulfate SO4 2 minus exchanged on the surface bed of anionic exchange resin. After exchanging cation and anion, completely the water free from dissolved contaminant. One of the step removed cation and another step removed anion, which means completely that salt is removed by step-by-step process. Here after removing cation and anion, that water is completely free from dissolved contaminants. The remaining third step is going to involve like this. Here third step, formation of water, H plus from step 1, H plus is coming from step 1 and OH minus is coming from step 2. These two are combined to get water. This water is said to be what more? Deionized water, which is called what more? Deionized water or demineralized water, which is said to be what more? Deionized or demineralized water. This is the process ion exchange process. Here what are the advantages of ion exchange process? Means it is 100%, most probably dissolved contaminants are going to remove, it is, but only one disadvantage for this method, it is expensive method. It is 100% dissolved contaminants are removed, but here what more, this method is expensive and also you are using expensive chemicals. Before going to this method is not going to work number of days. number of days, it is also going to work 1 year, 2 year. After that, we need to regenerate these resins. These resin beds are what more? Microporous, like previous zeolite method. These microporous structure exhausted due to continuous exchange of cation and anion respective tanks. Here, whenever these resin beds are exhausted, that time regeneration is required. Regeneration of resin is required. Here, regeneration of resins are required. Here, regeneration of resins. How to regenerate means, first one, cation exchange resin. How to regenerate? This one you need, RCOOH we need. This one we need to regenerate. Here what compound you are going to take? This one more. This reaction takes place. RCOO2Ca, RCOO2Mg you can take, and addition of dilute HCl. How to regenerate? Cation exchange resin can be regenerated by the addition of dilute hydrochloric acid. Cation exchange resin bed is regenerated. How to regenerate? Cation exchange resin can be regenerated by the addition of dilute hydrochloric acid to regenerate what more? Cationic exchanging resin. I am showing the reaction. You see here, RCOO2Ca is going to combine with 2 moles of hydrochloric acid to obtain 2 moles of RCOOH, remaining calcium chloride. In a similar manner, RCOO2Mg plus 2HCl to obtain 2RCOOH plus MgCl2. Here you can check it. This is what more? Resin. Fresh resin again regenerated. It is going to further filtration continuously. This calcium chloride and magnesium chloride are living from washings. This calcium chloride and magnesium chloride living from these washings. Here what more? Calcium chloride, MgCl2 living from here. Whenever regeneration. Next, anion exchange resin. Anion exchange resin, R-OH we need. You can take what more? R-Cl. R-Cl is going to combine with what more? Sodium hydroxide to produce what more? R- and OH combined to produce what more? R-OH. Resin is regenerated and remaining chemical is formed, sodium chloride. Next one more you can take, R-HCO3 combined with sodium hydroxide to produce R-OH, again fresh resin regenerated by forming of NaHCO3 to come sodium bicarbonate. Next one more chemical also is there, R-2SO4 is going to combine with 2 moles of NaOH to obtain 2 moles of R-OH plus remaining Na2SO4 to produce Na2SO4. All this NaCl, NaHCO3, Na2SO4 are living from washings. Means here removing NaCl, NaHCO3, Na2SO4 etc. removing from these areas. This is complete what more information about ion exchange process. Exam point of view, very important. Okay, dear student, everyone subscribe the Ask Engineering Academy channel and also like and comment. Okay, once again I am repeating, all the students to subscribe the channel and like and comment about this academy. Next I am going to explain reverse osmosis. You can see. reverse osmosis. What is reverse osmosis? Before going to this reverse osmosis, I would like to explain osmosis. Here listen now, what is meant by osmosis? The process of diffusion of solvent, molecule from lower concentration to higher concentration through a semi-permeable membrane is known as reverse osmosis. Here what is that? The process of diffusion of solvent molecule from lower concentration to higher concentration through a semi-permeable membrane. Semi-permeable membrane is known as what more? Osmosis. But here our topic is what more? Reverse osmosis. Here once again I am explaining here the process of diffusion of solvent molecule, from higher concentration to lower concentration or high concentration to low concentration through a semi-permeable membrane is known as what more? Reverse osmosis. Actual what did I say osmosis? The process of diffusion of solvent molecule from lower concentration to higher concentration through semi-permeable membrane. That osmosis process, whenever it goes to reverse direction, means some osmotic pressure you can apply on concentration side. That osmosis can goes to reverse direction. The osmosis process exactly goes from lower to higher concentration. But whenever applying some osmotic pressure on concentration side, the solvent molecules are flowing from higher concentration to lower concentration through a semi-permeable membrane. Here I am giving the definition once again. The process of diffusion of solvent molecule, which means water molecule, higher concentration to lower concentration through a semi-permeable membrane is known as what more? Reverse osmosis, whenever applying osmotic pressure only. Here the seawater also is treated in this process. Seawater is the most impure water. Which contains lot of dissolving salts. Here the common sodium chloride NaCl present in the water, this water is also said to be what more? Brackish water. Here the brackish water means what more? Sodium chloride whenever dissolve in the water called what more? Brackish water. The process of removing common salt NaCl from the water is also called as what more? Desalination. Here after the definition you can take a small diagram. Here what you are taking in middle, semi-permeable membrane you can fix. You can take one tank, semi-permeable membrane which allows only solvent molecules. What is this? Semi-permeable membrane. Here apply some osmotic pressure. What is this? Seawater. Here 10 to 40 kg centimeter square you can apply pressure. Here seawater contains most of the salt as dissolving state, which means impure water. Whenever osmotic pressure applied, the water is flowing slowly towards semi-permeable membrane. The semi-permeable membrane having small microporous structure, it allows only solvent molecule, which means water molecule, which do not allow the salt particles. Salt particles are stopped on the surface of this bed. Here pure water is coming down. Pure water is called what more? Pure water is getting down. It is going to collected from here. Very simple process. Here the process of diffusion of solvent molecule from higher concentration, which means seawater contains most of the salt. Highest salt indicates what more? More concentration. after the purification to get least salt, least after the purification having any salts, whatever required amount that only present in that. That is a less concentration, that is what more lower concentration, which means the water is goes from higher concentration to lower concentration in reverse osmosis process. Reverse osmosis process. Here what are advantages means here sea water and also brackish water also treated in this process. Here what more, in this process most probably to obtain 30 to 40 ppm hardness it is permissible only. Potable water up to 125 ppm nothing will happen. Here advantages, this process excellent and reliable process, this process excellent and reliable process. Here what more, reliable process and excellent process, excellent process. Here after purification to get only 30 to 40 ppm hardness, 30 to 40 ppm hardness it is permissible hardness only. Here not required heavy chemicals here, that is also just to skilled operator, just to some external source, one external what more pressure is required, no, except external pressure not required anything here, skilled operator also not required. And also disadvantage is what more, what is the disadvantage, mainly mostly some water is going to wasted in the drain. Nowadays water is a what more, water is a natural source, you are going to waste means during the purification process mostly how much liters of water is going to purify, same equal amount of water is going to wasted in drain. That is except the disadvantage, remaining everything okay. This is reverse osmosis process, reverse osmosis process. After that we have very important topic, Nalgonda technique. Nalgonda technique. Here in Nalgonda technique, here mainly described, Nalgonda technique mainly described to remove fluorine from the water. What is the main aim of Nalgonda technique means? What is the main aim of Nalgonda technique means? What more? Removal of fluorine from water. What is the main aim of Nalgonda technique? Removal of fluorine from water. If in case fluoride water, if any people continuously drinking, what's happening, you know? Here fluorosis occur, that people suffered on fluorosis, mainly teeth decay, bone decay occurs, bone decay occurs. That's why fluoride is removed from the water. Whenever fluoride removed from the water, the people are safe from fluorosis, safe from fluorosis. Here listen more, here what is the main aim of to removal of fluorine, to removal of fluorine from water, to removal of fluorine from water, or maintains optimum level means mostly do not exceeds 2 ppm, fluorine do not exceeds 2 ppm means less than 2 compulsory, less than 2 compulsory. Here this Nalgonda technique was explained by Neary. Nalgonda technique is going to explain what more? Neary, National Environmental Engineering and Research Institute. What is that? National Environmental Engineering engineering and research institutes, research institute. Here what more? Nalgonda technique was developed by research National Environmental Engineering and Research Institute, which was located in Nagpur. Here in Nalgonda technique, majorly what are going to mix? Here Nalgonda technique, what is the main aim? To removal of fluoride water, to removal of fluorine from water, or to maintain optimum level of fluorine. Here also I am giving the what more, the process of removing fluorine from water is said to be what more, defluoridation. Here what is the definition? The process of removal fluorine from water, the process of removal fluorine from water is said to be what more, defluoridation. Here what are chemicals are going to mix? Here what more, in Nalgonda technique the chemicals mix, chemicals what are going to take? Aluminium salts, means Al2SO4, Al2SO4 taken twice, Al2SO4 taken twice, comma, lime, comma, bleaching powder. Here these chemicals, what more, rapid mix of these chemicals, what are they? Aluminium salts, lime, CaO, bleaching powder, CaOCl2, bleaching powder. These three chemicals are going to rapid mix. What's happening, you know, here whenever rapid mixing, slowly the dissolving salts are going to precipitation takes place. Here slowly what happen, whenever aluminium salts, calcium oxide, lime and bleaching powder, whenever rapid mix with this water, what happen, dissolved calcium and magnesium salts are going to slowly precipitate to obtain what more, slowly precipitations occur. That precipitations are going to settle based on the gravitational force bottom of the tank, that is said to be what more, sedimentation process. Whenever this rapid mixing of these three compounds, dissolving calcium and magnesium salts are going to precipitate and slowly settle bottom of the tank, that is said to be what more, sedimentation. After sedimentation, whenever dissolving suspended colloidal impurity is not going to precipitate, it takes time again after the sedimentation process, slowly that are going to precipitate. While adding up all these chemicals, thus precipitations are formed. Thus precipitation can be removed by what more, filtration process. Here what are going to form? Sedimentation. After that what more, flocculation. After removing, what more, according to gravitational force, somewhat what more, dissolving particles are settled bottom of the tank. After removing, dissolving suspended particles are precipitated, which are all called what more, precipitated substances is said to be what more, flocculation process. Flocculation can be, after that what more, filtration. After that what we are going to do? Filtration. After filtration, what are going to do? Disinfection, you can do it. What more? Disinfection purpose, what are going to add? Calcium chloride is calcium. Bleaching powder is going to useful for disinfection purpose. Here what is going first? Whenever lime is going to add, lime is combined with dissolving salts, they form dissolving impurities are going to precipitate, sedimentation takes place. After that This alum, which is called alum aluminum salts, is going to react with colloidal suspended impurities. Again, flocculation or precipitation takes place. The precipitation can be filtration. After the filtration, what more? The remaining can be treated with calcium CaOCl2 bleaching powder. The dissolved, the presented bacteria, virus, fungi, etc. removed by disinfection process. This is what more? Nalgonda technique. The main aim of this experiment is what more? To minimize the fluorine, or to keep as optimum level fluorine, which means what is the optimum level of fluorine? Optimum level of fluorine, optimum level of fluorine in water, optimum level of fluorine in water do not exceeds 2 ppm. Do not exceeds 2 ppm means to minimize below 2 ppm or to remove complete fluorine also, it is said to be what more? Nalgonda technique. Nalgonda technique. This is about what more? Water and treatment unit. Next I am going to continue the class. Before going to continue, everyone do subscribe more. Everyone do subscribe and like the channel and also comment. Okay. Next I would like to start one more unit, electrochemistry. 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 Here, electrochemistry, we are going to study about what is conductor, what is insulator, what is electrolyte, what is non-electrolyte, and types of conductors and electrolysis process, Faraday's laws, and electrolysis of fused sodium chloride, electrolysis of aqueous NaCl, etc. we have in syllabus. According to your syllabus, before going to this, I am going to introduce about electrochemistry. Electrochemistry means what more? It is a branch of physical chemistry. It is a branch of physical chemistry which deals the relationship between electrical energy and chemical energy. Once again I am repeating, what is electrochemistry? Electrochemistry is a branch of physical chemistry which deals the relationship between electrical energy and chemical energy, which means vice versa. Here what more? What is the relation to electrical energy into what more? Chemical energy, or chemical energy into electrical energy. Chemical energy into electrical energy, which is also called as what more? Vice versa. Vice versa. Enter the electrochemistry, what phenomenon is going on? Either conversion of electrical energy into chemical energy, or chemical energy is going to convert into electrical energy. Chemical energy is going to convert into electrical energy, which is called what more? Vice versa. Vice versa. Enter the electrochemistry, this phenomenon is going on. I am not going to introduce complete introduction about depth introduction. Here what are having in the syllabus I am going to discuss with you. And now I would like to introduce conductor. What is meant by conductor? A substance which allows the passage of an electric current through it is called conductor. A substance which allows the passage of an electric current through it is called conductor. What are examples? Conductor: all metals, alloys, and fused salts, acids, bases, etc. all this what more? Conductors. Fused salts, comma acids, comma bases, etc. are going to act as what more? Conductors. Here what is meant by non-conductor or insulator? Insulator. A substance which do not allows the passage of an electric current is called what more? Insulator. A substance which do not allows the passage of an electric current. Passage of an electric current is called what more? Insulator. What are examples? Paper, plastic, wood, etc. is going to act as what more? Insulator. The simple one more question, maybe they are asking what is meant by conductor. Give an example. A substance which allows the passage of an electric current through it is called what more? Conductor. All metals, alloys, alloys means mixture of metals, fused salts, acids, bases, etc. Insulator means what more? A substance which do not allows the passage of an electric current is called what more? Insulator. Paper, plastic, wood, etc. is stated as what more? Insulator. Here next we have types of conductors. Types of conductors. You can see here. Directly I am going to explain like differences in our examination point of view. They are asking what are the differences between conductors and what are the difference between metallic conductor and ionic conductor. Here total types of conductor, metallic conductor and ionic conductor. Here I am writing metallic conductor, ionic conductor, ionic conductor. Here the differences are very important for exam point of view. Metallic conductor and ionic conductor. Here the conductors which conduct electricity, flow of electrons. Here what more? The conductors which conduct electricity with flow of electron. Here what more? Flow of electrons. The conductors which conduct electricity, flow of electrons. But here the conductors which conduct electricity, flow of ions. Here what more? The conductors which conduct electricity with flow of ions. These two are conductors, but in metallic conductors, what more? The conductors which conduct electricity with flow of electrons, but in ionic conductors, these are the conductors conduct electricity with flow of ions. Here dear student, everyone subscribe the channel and like and also comment, and also everyone listen and what more, subscribe and like the channel and comment in the comment section how this classes we are going to understood, also comment. Okay, dear student, you can like the channel and also comment okay how these classes are going on, also you can comment, etc. how you can understanding the classes including chemistry, physics, mathematics, etc. especially for diploma classes. Students, after the listening classes, if you have any doubts, you can comment and also explaining in next class. I am also available here today. We have exam tomorrow. I thought this general engineering chemistry diploma, and also everyone like the channel and comment and subscribe the channel. Then only comment your comment section. You can comment how you are understanding the subject. If you have any doubts, you can post it. I will do it another class. I will arrange another class also for you. Okay. All the best. Okay, now I am going to continue the class. Here differences between metallic and ionic conductors. Metallic and ionic conductors. Here check it more. Flow of current takes place. What more? Metallic conductors, flow of electrons, and what more? Flow of ions. Here what more? No chemical reaction takes place. No chemical changes. No chemical changes. Here what more? Chemical changes occurs. Chemical changes occurs. Chemical changes occurs. Here no transfer of matter. No transfer of matter. Here transfer of matter takes place. Transfer of matter takes place. Transfer of matter takes place. Here what more? Conductivity decreases with increasing temperature. Here what more? Conductivity decreases. Here what more? Conductivity decreases with increasing temperature. Here what more? Conductivity increases with increasing temperature. But more, these are the few differences I am showing here. These are the conductors, conduct electricity, flow of electrons. These are the conductor, conducting electricity, flow of ions. No chemical changes occurs. No transfer of matter takes place, etc. Differences are very important for the exam point of view. Okay. Next I am going to explain electrolysis of fused sodium chloride. Electrolysis of fused sodium chloride. Here electrolysis, fused sodium chloride takes place in electrolysis process. This electrolysis carried out in electrolytic cell. Electrolysis is carried out in electrolytic cell. Here this electrolytic cell consists of two electrodes. These two electrodes are connected in what more? Electrolysis is said to be what more? Two electrodes are connected in what more? In this cell. This is what more? Electrolytic cell. This electrolytic cell consists of two electrodes. One is anode. What is this? One is anode. Another one is what more? Cathode. Another one is cathode. These two are connected through a battery. Anode is positive, cathode is negative here. What more? This is what? Battery. Okay. This electrolytic cell carried out what more? Electrolysis process of fused sodium chloride. It consists anode and cathode and battery. This complete construction is said to be what more? Electrolytic cell. Whenever you are using as what more? Fused sodium chloride is used as what more? An electrolyte. Fused sodium chloride is used as an electrolyte. What's happening? Check it. NaCl, dissociation takes place like dissociation of NaCl. Here I am writing NaCl is going to dissociate Na plus and Cl minus. Na plus and Cl minus. Here what's happening? Whenever this Na plus and Cl minus are present here, Na plus Cl minus present in this water, many, I am writing here only one Na plus and one Cl minus, many of Na plus and many of Cl minus are present here. These ions are moving towards oppositively charged electrodes. Here already anode and cathode present in this electrolytic solution, and this anode contains positive charge, which means negative terminals, negative ions, negative is going towards anode and positive ions are going towards cathode. Positive ions are going towards cathode. At anode, what's happening? At anode, what is anode? Positive charged electrode. Positive charged electrode, here what's happening? Cl minus at anode oxidation takes place. 2 moles of Cl minus gaining of what more? 2 electrons to produce what more? Cl2 gas. At cathode, what happened? At cathode means negative charged electrode, 2 sodium plus ions combining with what more? This one is reduction reaction takes place to converts 2Na by the liberation of 2 electrons. Here what more? At cathode reduction reaction takes place, at anode oxidation reaction takes place. Check it here. Chlorine is going to liberated at anode, which means chlorine is going to liberated at this area. Chlorine is going to liberated at this area, and sodium is going to deposited here. Sodium is going to deposited here, and chlorine is going to liberated at this electrode. This is what more? Electrolysis of fused sodium chloride. The process of decomposition of sodium chloride. During the electrolysis. In electrolytic cell, the following manner, dissociation reaction is going to take place like this. NaCl is going to convert into Na plus Cl minus. At anode, what happened? After dissociating NaCl, Na plus and Cl minus ions are produced. Okay. This Na plus and Cl minus ions are going to move towards oppositively charged electrodes, which means sodium plus ion is going to move towards cathode, Cl minus ion is going to move towards anode by taking place anodic and cathodic reactions. After taking place anodic and cathodic reactions, chlorine gas is going to liberated at anode and sodium is going to deposited at cathode. This is what more? Electrolysis of fused sodium chloride. This is very important for examination point of view. Next I am going to explain Faraday's laws. Very important. Here listen, Faraday's first law. Dear students, everyone subscribe the channel and like and comment in comment section. And now I would like to explain Faraday's first law. Here listen more. Faraday's first law, the process of decomposition of an electrolyte. During the electrolysis, deposited or liberated at electrodes is directly proportional to the quantity of electricity is passed through it. Here what once again I am repeating Faraday's first law, the process of decomposition of an electrolyte during the electrolysis is directly proportional to the quantity of electricity is going to pass through an electrolyte, which means once again I am repeating, mass of substance is directly proportional to the quantity of electricity Q. Here what more? The mass of substance deposited at electrodes during the electrolysis is directly proportional to the quantity of electricity is passing through it. Here what more? Here m is equals to, I am taking what more? Proportional constant I am removing, EQ I am writing. Therefore Q is equals to what more? Current into time. Q is equals to quantity of electricity, current into time. Q is equals to CT into T. Q is equals to CT. Here once again I am repeating, the mass of substance deposited or liberated at electrodes during the electrolysis is directly proportional to the quantity of electricity passing through it. Mass of substance is directly proportional to the quantity of current. Here m is equals to ECT. Here where m is equals to mass of substance. Q is equals to quantity of current or quantity of electricity, next E is equals to electrochemical equivalent, but Q is equals to CT. This term you can substitute here. What will get? M is equals to what more? E as it is same, Q place CT or C into T. This is what more? Faraday first law. Once again I am repeating, Faraday first law, the mass of substance deposited or liberated at electrode during the electrolysis is directly proportional to the quantity of electricity passed through it. M is directly proportional to Q. M is equals to, from proportionally constant here I am taking, E is equals to electrochemical equivalent, but Q is equals to CT. You can substitute to get final equation. M is equals to CT. This is Faraday first law. Then after we have Faraday's second law. Faraday's second law. Here Faraday's second law statement you can listen here. If the same quantity of current is passing through the different electrolytes, the weight of substance is directly proportional to the equivalent weights. Here what more? If the same quantity of current is passing through the different electrolytes, the weight of substance deposited or liberated at electrode is directly proportional to their equivalent weights. Once again listen, I am repeating the statement. Here what more? If the same quantity of current is passing through the different electrolytes, the mass of substance deposited or liberated at electrode is directly proportional to their equivalent weights. Here if suppose here I am taking two electrolytic solution, for example this is one. Here what solution I am taking? Silver nitrate. Here also what I am taking? Copper sulfate I am taking. Same quantity of electricity is going to pass. Connect. Here what more? These two are different electrolytes, silver nitrate and copper sulfate, but same quantity of electricity passing through different electrolytes. What did I say? The weight of substance deposited or liberated at electrodes during the electrolysis is directly proportional to their equivalent weight. Here this one W1 weight of AgNO3, E1 equivalent weight of AgNO3. Here W2 is equals to weight of CuSO4. E2 is equals to equivalent weight of CuSO4. What did I say in my statement? Weight of substance deposited or liberated electrode is directly proportional to their equivalent weight, which means W is directly proportional to E. W is directly proportional to E means W1 is directly proportional to E1, W2 is directly proportional to E2. Okay. According to this, weight of substance deposited or liberated electrode is directly proportional to their equivalents. Means W is directly proportional to their equivalent, means W1 is directly proportional to E1 and W2 is directly proportional to E2. W2 is directly proportional to E2. Here this equation is going to, at what more, a small constant you can write. W1 is directly constant, you can take what more, if any one constant you can take KE1. This proportionally constant. This is equation 1. Here W2 is equals to K into what more, this one E2, this one also equation 2. Equation 1 and 2 we can do it. Equation 1 and 2 divide W1 by equation 1 divide by equation 2 to get what more, W1 by W2 is equals to what will come, E1 by E2. E1 by E2 to come. This is final equation. Whenever equation 1 divides with equation 2, W1 by W2, K cancel to get what more, W1 by W2 is equals to E1 by E2. This is what more, Faraday's second law. Faraday's second law. W1 by W2 is equals to E1 by E2. Okay students, if you take another electrolyte, third, fourth also you can take. Here I am showing with the two electrolytic solutions by passing same quantity of current. If you are taking another electrode also, 3, 4, 5 also you can take also to get same equations. W1 by W2 is equals to E1 by E2. Okay students, everyone you can subscribe this online classes channel and also subscribe and like the channel, and comment section you can comment and also post your doubts. It will explain next classes whatever the doubt you are posted. Okay students. Okay, now I am going to wind up the classes. Almost I was discussed today what more, water and its treatment and electrochemistry as important questions today. Okay, all the best students for tomorrow exams. Thank you very much.
Hello. Yeah, hello. Wait a minute. Right. Hello. Wait, sir. Hello. Hello. Yes.
వస్తుందా ఇక్కడ పెట్టుకుంటే? హలో. ఓకే, మొత్తం క్లోజ్ చేద్దామా? Yes, today I am going to discuss about diploma engineering chemistry topic, water and its treatment. Water and its treatment. First of all, I would like to introduce about source of water. Source of water. What is source of water available? Here one is groundwater. One is groundwater. Groundwater means what more? What is that? Pond, and what is that? Borewell water, etc. is treated as what more? Groundwater. And second one is what more? Surface water. Surface water. Surface water, majorly rainwater, river water, lake water, etc. is said to be what more? Surface water. These two are what more? Naturally occurring sources only. It is naturally occurring sources only. Here this naturally occurring source contains lot of impurities and dissolving salts. Lot of impurities and dissolving salts. Here these salts and impurities and minerals etc. are going to add into the water. But here one thing, the human beings nowadays for drinking purpose not required that much dissolving salts and other impurities are not required for drinking purpose. That purpose we need to study what is hardness and how to remove hardness etc. topics. Now I would like to introduce what is hard water. What is hard water? This very important for examination point of view. Hard water, what is the definition? Here what is hard water? The water which do not gives lather with soap is called what more? Hard water. Here what is the definition of hard water? The water which does not produces lather, with soap is called hard water. HW, hard water. It means, what is the chemical formula of soap? Hard water means which contain dissolving salts. For example, what is soap chemical formula? C17H35COONA, sodium salt of stearic acid. This compound is said to be what more? Soap. Whenever combined with any one of the dissolving salts you can take. For example, magnesium chloride I am taking, or dissolving salt. By dissolving of this magnesium chloride, here hardness occurs water. Here this one is combining 2 moles of soap, here form like this C17H35COO 2 times and magnesium. What is remaining? Here 2 sodiums and 2 chlorines are formed like this, 2 NaCl as a byproduct. Here by forming like this compound, this precipitation to form, that's why immediately do not come lather with this hard water. Here similarly we have soft water. soft water. Soft water means, here what is the definition? The water which gives much lather with soap. The water which gives much lather with soap is called what more? Soft water. The water, here I am writing, the water which gives much lather with soap is called soft water. Is called soft water. Here once again I am repeating, the water which gives much lather with soap is called soft water. Soft water means which do not have any salts, which do not have any dissolving salts. Due to dissolving salts of calcium and magnesium, here the water occurs hardness more. The water occurs hardness, and also some cases some traces of heavy metals also to produce hardness. Here directly whenever soap is going to react with soft water, which means only H2O, they do not have any dissolving salts, only H2O is directly going to react, they produce what more? C17H35 COOH plus remaining NaOH to come. This is hard and soft water. Once again I am repeating, hard water means the water which does not produces lather with soap is called what more? Hard water. Whenever hard water reaction takes place like this manner, C17H35 COONA is going to react with magnesium chloride to obtain what more? Like C17H35 COO2 Mg plus 2 NaCl. That is hard water. Next, soft water, the water which gives much lather with soap is called soft water. The soft water reaction this. Next I am going to explain about next one. Here types of hardness of water. Hardness causing salts. Now I am going to explain what more? Hardness causing salts. Then after I would like to explain types of hardness of water. Here hardness causing salts. What are the salts causing? What are the salts causing or responsible hardness? What are the salts causing or responsible hardness causing salts mean the following salts are causing hardness means bicarbonates, chlorides, sulfates, nitrates of calcium and magnesium are responsible hardness. Here calcium and magnesium salts are responsible calcium and magnesium salts are responsible hardness causing salts. Here what exact salts are responsible hardness causing salts means what more? Bicarbonates of calcium and magnesium. Next chlorides of calcium and magnesium. Sulfates of calcium and magnesium. Nitrates of calcium and magnesium. Here calcium and magnesium bicarbonate CaHCO3 taken twice, calcium bicarbonate and magnesium bicarbonate. Next chloride CaCl2 MgCl2. Next sulfate CaSO4 MgSO4. Next nitrates calcium nitrate, magnesium nitrate. These are the salts responsible hardness. Mainly these salts are going to dissolve in water, the water occurs hardness. If in case these salts are absent, the water do not have any hardness, which means completely that water is free from the hardness. whenever dissolving these salts in water, the water occurs hardness. Completely these following salts are absent in the water. The water do not having any hardness, do not have any hardness. Here based on these salts, based on the dissolving salts, here hardness of water divided into two types. Hardness of water is going to divided into two types. Here hardness of water, hardness of water. Hardness of water, before going to types of hardness of water, I am giving this hardness of water definition. Once listen. Previously, I gave the definition of hard water. What is hard water? The water which does not give much lather with soap is called what? Hard water. Here, what I am giving the definition of hardness of water, the property of hard water which prevents the formation of lathering with soap. Here, what I am giving, listen carefully. The property of hard water which prevents the formation of lather with soap. The property of hard water, the property of hard water which prevents the formation